12.2, Properties of Alcohols and Ethers. Now, let's first address the solubility of alcohols in water. Well, alcohols contain the polar OH groups, and we've learned a lot of this term of the hydrogen bonding, and it's coming back again and again and again and again, and it's a very important part of life and of our human bodies also. Well, alcohols have this OH group, we know they're polar, and they can form hydrogen bonds with other alcohol molecules or with water. And alcohols that have only 1 to 3 carbons are soluble in water due to the hydrogen bonding. So if we look here at this example on the right, we have a 1 carbon alcohol. So we have methanol. So we have our carbon group here, and we have our oxygen, and we have our hydrogen here. Well, our OH, because the oxygen was partially negative, and because it has those two sets of those two pairs of unshared electrons here and here, first of all, those unshared pairs of electrons are attracted to the hydrogen of a water molecule that's partially positive. Actually, the hydrogen that's partially positive is attracted to the unshared pairs of electrons here. They have something both that they have in common. And this has the electrons, this needs the electrons, so there's this attraction. This attraction is the hydrogen bonding. And so on the oxygen itself of the alcohol, it can form 2 hydrogen bonds with 2 water molecules, and then with the hydrogen end of the alcohol, it can also form a hydrogen bond between it and the lone pair of lone electrons, unshared electrons on the oxygen of the water molecule of another one. So we have a total of 3 water molecules that have this attraction, and if you go back and remember, like attracts like dissolves like, then we have this idea that this alcohol can dissolve in water. However, once our carbon chain gets longer than 3 carbons, the solubility decreases. And the question could be, why? Well, because then you have more of the molecule that is the carbon and hydrogen only and is the nonpolar side. So if we were to have more nonpolar side of our molecule than the polar side, then that's going to inhibit the ability to form these attractive forces, these hydrogen bonds with water, which means it inhibits the ability to be soluble in water. If we look at table 12.1, you will notice with 1 carbon and the OH, very soluble, and 2 carbons, very soluble, totally soluble, 3 carbons soluble. By the time we get to 4 carbons of our alcohol, it's now only getting to be slightly soluble. Why? Because we have a longer chain that is of the molecule that is non-polar, and this side right here, the OH side, is just a little bit is polar, but it's just a little bit of the molecule. So the molecule is much more has much more space that's non-polar, and so that is not going to be dissolving in the water. So by the time you get to a 5 carbon alcohol, it's totally insoluble, meaning doesn't dissolve in the water. Now let's talk about ethers. Ethers didn't have the polar OH group. They did have an O. They had the O bonded to a carbon on one side and a carbon on the other. So it's not like they're totally not soluble, because they do have these unshared pair of electrons still around the oxygen. And if something is nearby that has the hydrogen that can participate in hydrogen bonding, it can, now watch the terminology, it doesn't form hydrogen bonds, but it can participate in hydrogen bonding with a molecule that has hydrogen bonding. Now, it's slightly soluble, as long as there's 4 carbons or less, but by the time we get to 4 carbons, it is not soluble anymore. So if we were to compare the solubility of an alcohol to an ether straight up, the alcohols are much more soluble because of the amount of hydrogen bonding they can participate in. So indicate whether each of the following is soluble in water and explain why. Press pause and come back. So on A, we have 1, 2, 3, 4, 5, 6 carbon chains, alcohol. So even though the OH itself is polar and can participate in hydrogen bonding and can form hydrogen bonds, it is such a small part of our overall molecule, and our overall molecule is nonpolar, then this alcohol is non-soluble. It is not going to dissolve in water. It's not going to be soluble in water. All right, so here we have an ether with 3 carbons. It's still in the okay range, but it's only slightly soluble. Here we have a very short-chained alcohol, a 2-carbon alcohol, and so that's going to be good enough that the OH, the alcohol, will form, the OH will form hydrogen bonds with water. The carbon part is not long enough to totally encompass the whole molecule, and so yes, the carbon part is nonpolar, and the OH is polar, but the non-carbon is not, the carbon is not a lot of this molecule. As long as it's less than, as long as it's 3 or less, it's totally soluble. 4 or less, it's partially soluble. By the time you get to 5, well, it's not soluble at all. Too much non-polar items on there. Now, phenols. They're slightly soluble in water. Notice the word slightly. They have an OH group that can form hydrogen bonds with water. And you'll notice they can even react with water. If you look at this reaction here, they can react with water to produce phenoxide ions. And we learned earlier in an earlier section that they were once used as antiseptics.